There's a delay. I was waiting to say it. Okay, here we go. So we are today taking the first part of this, finding inverse functions. Tomorrow is going to be the same exact information, nothing new, but we will be just graphing it. I'm hoping to do kind of an art project with it, actually, because these inverse functions have interesting graphs. We're going to see about that tomorrow. But today, this is 2.7.1, part 1, and this is just a little review to get our mind in the right space for this. We've seen this before, function notation. We've seen this a lot. This is f of x. That's how you would say it. Okay. And remember, it's just reminding us what we plug in for x. Okay. If this was f of x is equal to x squared, and I did f of 3, right? I'd be plugging in 3 wherever there was x. It's just almost like a reminder notation. Helps us remember what the function is going to do. Okay. We also can recall that f of x, aka it's y. It has the same place in the equation. F of x is y. It's just in function notation for those other purposes that I was mentioning. Okay, so let's not get caught up on that. We know those are the same, just in disguise. All right. Next, we have this inverse operation table. We already know addition. What's the inverse? Subtraction. Multiplication, inverse. Division. The inverse of squaring something? Square rooting. How about the other direction? Does it work the other direction? What's the inverse of square rooting? Squaring. You see how these go both ways? What's the inverse of subtraction? Addition. So these are both ways because this is the inverse of each operation. Okay. If I have 1/5, the inverse of that is 5/1. So it's also just, we switch it. When there's a fraction, we flip it. It's a reciprocal. That's just a review. When we find the inverse function, which is the task for today, we're going to write the inverse function. We're going to label it f to this -1 exponent of x. So this is the inverse function of x. Inverse function of x. Go ahead and square that out. We have to make sure that our final answers, when we are talking about the inverse, we have to do the inverse function x with that notation. Otherwise, how do you know? How do you know which is the starting equation or not? All right. This is the key. This is the key point. The inverse switches the independent, our x values, and the dependent, our f of x values of a function. So remember that the independent, this is what goes in. This was all the x values. You can choose whatever you want. Nobody's binding that. You can choose whatever x values you want. It's independent what values you choose. But based on the values you choose for your x, this f of x is dependent on whatever x values you put in. So our f of x is that dependent variable. Okay. The key thing here is also, it's a switch in the reference of the problem. So I'm just going to pull this over here. Hopefully nobody unsubscribed for that. It's too wobbly. I'm getting sick watching it. Oh, when I'm doing videos, I do bad jokes too. That was bad joke number 1. There's more. Don't worry. Sweet. Don't you worry about that. All right, so let's look at this. Let's look at... No? All right, let's look at this right here. When I said this part, switching, it's a switch in the reference of the problem, okay? If we have a function that is looking at the profit from your tickets sold, profit from your tickets sold. So we'd have some profit from the tickets, right? Okay. When you take the inverse, it switches the reference. So let's look at this. What's different between profits from tickets sold and tickets sold to earn profit? You see how it just kind of like switches what the focus is. When we take the inverse, instead of looking for the profit by tickets sold, we would be looking for how many tickets do I have to sell to get a profit? Okay. You see how it switches the reference? It's here we're interested in the profit. Here we'd be interested in how many tickets. Okay. So just keep that in mind. We'll do this in a sec. We're going to use this process to assess this example problem, which if you want, you could also, it's in your book, your workbook, page 154, number 2. if you'd like to also make the notes for that there. But we're going to use this process every single time. I think that you'll see the actual process of it isn't that hard. The hardest part is kind of thinking about how it switches the reference. Okay. But here's our steps. We're going to replace f of x with y. So I'm actually going to redo this problem over here where it's a little easier to see. So here's the work I'd want to see. I'm going to take this example, f of x is equal to x plus 20. First step, replace f of x with y. Okay, we know those are the same. We know those are the same, so nothing really magical happened here. F of x is the same as y, I just placed it there instead. Switch your x and y variables. Literally switch your x and y variables. So wherever you had the x, that's where the y is going to go. Wherever you had the y, that's where the x is going to go. So I'm going to switch these and end up with x is equal to y plus 20. You don't switch the term. If it's x squared, you don't switch x squared over. You just literally, just the x and the y, pick them up, move them. Okay. Like if you had a piece of paper and you cut out little holes around the x and the y and you pick them up and you put them over and tape them to the other place. Like literally. Well, don't do that. Don't literally do that. Yeah, question?
Wait, so if we have the 12x, do we move the 12x over to the other side, or do we move just the x?
Just the x. Okay. Yeah, just the variable alone. One letter, x, y, move them, switch them. Okay? So you see I did that right here. Who is 100% confident that we can do this switch? That's the only weird thing that's different. It's just a switch, right?
It's just a switch.
All right, just a switch. Once you get the switch, now all we have to do is solve for the new y. Watch. Y plus 20, how do I get rid of the plus 20? Minus 20. So I have y is equal to x minus 20. Last bit, replace f of negative 1x, so f of the inverse of x, for y to show that it's the inverse. So I want everyone to look at this and tell me if you're okay with me doing this. I went from this step right here, to this step right here. Is that okay that I just moved the equal sign on the other side of the equation like that? What do you think? Stanley?
Isn't that just turning the addition symbol into a subtraction symbol?
Oh, you're talking about this step. I subtracted 20, 20, that gets rid of it on the right side. So x minus 20 is equal to y. It's not changing the symbol, actually. It's still minus 20. The only thing I did was, here's the deal. X minus 20 is equal to y. So y is equal to x minus 20. Same thing. I just read it the backwards way here. So this is equal to y. So y is equal to that. Right? X minus 20 is equal to y. So what I'm saying is y is equal to x minus 20. So I was able to just say, well, I want to change this to f of negative x, negative 1x. So I just put that here. Since y is equal to that, f of x is also equal to that. It's just rearranging the equation, just putting it on the other side, but we don't need to move it. I could have rewritten this like this. X minus 20 is equal to f of negative 1x. And what I'm saying is it doesn't matter. This is equal to this, right? This is equal to this. They're both equal to each other, so I could say it either way. I don't have to move anything around. I just have to say, well, no, f of x, f of negative 1x is equal to that. So that's how I'm going to put my final answer like so. Okay? You see how we did that one?
Yes.
Okay. So now I want to look at this example problem. And we are going to, instead of looking for the profit from the tickets, we're going to find the tickets sold to earn a profit. Okay. So let's use our steps. What should I do first? What do you think? Yeah, come.
Replace f of x with y.
Watch. Y is equal to 12x minus 600. All right, so follow along with this one example for sure. Okay. Now I did the replace, now I need to do the switch. What should I literally switch? X and Y. You see they're right here? In one moment, they're going to be switched.
Okay.
That's what we do. That's our process as far as doing the inverse. Watch. Now it's X is equal to 12Y minus 600. You see? So this was, we did replace, we did the switch. What's next? We need to solve. We need to solve. So let's see. I'm going to start by adding 600. Add 600. X plus 600 is equal to 12y. Think about what's going to be next. Good. It's 12 times y. To get rid of that 12, instead of multiply, divide. Watch. Do it there. Do it there. Do it there. 12 over 12 allows me to cancel that out. Now I have y left over on the right. We need to look at this and kind of make this a little easier to deal with. But I know my x over 12 can't really do much with that. Can't reduce that. 600 divided by 12?
50.
Yeah. Good mental math. I did my solve. What is my last bit here? I need to replace, right? And I already have it set up here. Here's the notation. Now everybody watch this for a moment. Y is equal to x over 12 plus 50, right? That's what y is equal to. So I could say, since I found my inverse, I could say my inverse function is equal to that same exact thing. I don't need to move it around. I could just place it on the other side, still equal to it. Make sure that that's okay. I didn't need to do anything to switch around the equation because they're both equal to each other. We can just do it that way. Okay. So now we have this new function, and I'm going to square this out. It's labeled correctly with inverse notation. And this tells me, now what I've figured out is, this is the number of tickets. The x value now is our profit. So you see that before we had the profit as a function of how many tickets are sold. Now we have the tickets as a function of how much profit we're going to get. You see how it changes the reference point? Instead of caring about the profit, now we care about the tickets. That's basically just the big idea about it. Okay, I'm going to have an activity either tomorrow or on the quiz that kind of looks at this for different kinds of businesses, because if you run a business, these aren't really hard to, these equations aren't really tricky to work out. Like for instance, this could be, each ticket costs $12, but you had to rent the theater for $600. So sell one ticket, you're not going to make a profit. You get $12 from your tickets, and it costs $600 to rent the theater. So you see, we have to get quite a few tickets to just even break even. You did good marketing. Got to do that. But this will be related. Honestly, I've used this in business before. Finding the inverse is super helpful. All right, what's the hardest part of this? All 4 steps? Yeah, we got 4 to deal with. Yeah.
I think it's tricky just remembering to switch the x and the y because I'm not used to having x equals, I'm used to having y.
Right.
That's equals.
Right, right. Remember that you have the liberty. If their things are equal, you can switch everything. You can flip the entire thing out. It doesn't change anything. So if it helps you, and you heard what Mara said and you agree, then take this after you replace it. Excuse me. After you replace it, and just sit around 12y minus 600 is equal to x. Maybe that'll be a little helpful because y is on the left side now. If it's not, don't do it. It's just when it's equal to x. Okay. So it is working in a slightly different way. All right. So how do we outro this video? All right. How about subscribe on 3? Should we do a whisper subscribe or a loud one?
Loud one.
Let's do our whisper first. All right, subscribe on 3. 1, 2, 3. Good creepy factor. All right, how about a louder one? Subscribe on 3. 1, 2, 3.
Subscribe!
Oh yeah, 75th gets a Kit Kat.
Wait, what is it at right now?
Yeah, I think it's at 55. Yeah, really? I'm gonna unsubscribe and watch it.
Unsubscribe